So today is March 2nd, and we're going to learn how to find the inverse of logarithmic functions. Tomorrow we'll find the inverse of exponential functions. So just like when we found the inverse of radical functions, this class did, by the way, exceptionally well on that last page of your test. There are 4 steps. You may remember the first step. If you forgot, it would be take f of x and turn it into a y. What was step 2? Switch them. What's step 3? Solve for the variable y. And what's step 4? Right. Okay, it's going to be very similar to that. Very similar. Okay, so if you've noticed, since I'm just teaching you how to do this for the first time, I didn't even put an f of x in, I just used a y. So we don't have to switch them. So step number 1 is switch the x and y. And now step 2 is we want to isolate the y. We want to solve for y. So to do that, I look y is on the right-hand side. And I want to eliminate anything that's around it. So it's like I'm peeling away an onion, getting rid of stuff on the outside. So first I need to get rid of the log base 5. So I focus on what the base is. The base is 5. That's going to be a hint. So I'm going to now treat this as an exponent, and there's the base. And whatever you do to the right-hand side, you must also do to the left-hand side. Now on the right-hand side, the whole purpose of doing that is so now when I simplify this, log base 5 and the 5 that is the base cancel out. I bring down negative 3y equals 5 raised to the x. To isolate the y, divide both sides by negative 3. And whether you keep the negative sign down below, put it on top or off the side, does not matter as long as only one negative exists. This represents the inverse. Problem is done. If you're sitting in somewhere like Ulysses, if it's hard to see, feel free to move your desk around, or Anna, the same thing. Please look right now at problems 2, 3, and 4. Look at problems 2, 3, and 4. Do you see how 3 and 4 are very similar and 2 is slightly different? What's the difference? That's a good guess, Diego. That's not what I'm looking for, but that's a good guess. Parentheses. What that means is I must include this 4 with the x. It's x plus 4. It's all part of that log. Over here, we just have a minus 5 or a minus 6 behind it, okay? So it's going to look a little different in your final answer. We're going to start with number 2. Switch the x and y. And similar to number 1, we want to get to the y. So peeling away like an onion here, I want to get rid of log base 4. Focus on what the number is at the base. So base, exponent, base, exponent. Now the 4 and the exponent of log base 4 cancel. I bring down y plus 4 equals 4 raised to the x power. Subtract 4 from both sides. Y is now isolated. And that's my final answer. I'm going to do number 4 because it's directly underneath and I'd like to compare 2 and 4. Put a line through the equal sign, separating the left and right. Switch the x and y. Now this time there's no parentheses. That means to get to this y, before I even start to take away the log and figure out how I can cancel it, I need to get rid of the 6. So to get rid of a negative 6, you're going to add 6. Now to isolate the y and remove the log base 2, focus on what the base is. The base is a 2. 2 becomes the base on both the left and the right to keep this equation balanced. So again, whatever you do to the left, you must do to the right. And in doing so, I'm able to simplify here and cancel out the base of 2 and the log base 2. So where students felt confused in previous hours was, how do I know when it's going to be like an x plus 6 in the exponent position, or when that number stays at the same level? So if you're confused, notice that here it stayed in parentheses, so it was an x plus 4, and in our final answer we had a number that was in back of the base. But when the number was separated from the log, then it joined the exponent. Do you see the difference? With your partner right now, you're going to have a minute and a half. You're in groups of 4. Please choose one person to work with, so everybody's in groups of 2. Except for Sergio, you'll go with a group of 3 here. And I want you to only do 2 problems. I want you to do number 3 and number 7. When you're done, look up at my answers to see if we have the same. 3 and 7, begin. Please check your answer for number 3 and number 7. Does anybody have any questions for me on 3 or 7? All right, number 5 and 6 are very similar. They're a little bit more difficult. We're going to start with number 5. So let's look at 1 through 4 and number 7. How do they differ from 5? There's one thing really that's different. Turn to your partner. What is that difference? Has a power behind, right? The number behind the base. Okay, so it's going to be just one extra step is what it involves. Here we go. So first we're going to switch. Now again, you're thinking of this like an onion. You're peeling away the pieces. You want to eventually get to the y. What's the first thing you're going to take off here? Log base 2. So you focus on the base, which is 2. Do that to both the left side and the right side. Now here's where the confusion comes in. People are like, well, what do we do? Well, do we want to solve for x or y first of all? Y. So you want to get y by itself. So what do you have to get rid of? The 3. So this is where the confusion comes in. Now listen closely. When you're trying to solve for a variable that's in the exponent position, we use logs. And the log base we use is based on the number you're trying to get rid of. So just like we did before, whatever you do to the left, you must do to the right. So please write log base 3 on both sides. And then I'm going to write in what already existed. On the right-hand side, I'm going to cancel out the log base 3 and the 3. And I get to bring down the y. On the left-hand side, I have log base 3 of 2 raised to the x power. Definitely a little more difficult. So what I want you to do before we go over 6, I want you to choose one person between the two of you who feels like they can explain it and see if they can do that in 20 seconds. Choose that person quickly. Ready, get set, and begin explaining. Go.
So, first I'm going to do illustration.
Ben, will you explain to your whole group if they don't understand, please? Sergio, will you involve yourself in one of those discussions?
Or not, take two,
Okay, so here's what I want you to do. Ready? Without raising your hands, I want you to think to yourself on a scale from 1 to 5, how well do you understand this problem right now? Don't raise your hands, just think to yourself, 1 to 5. I understand this is much more difficult than the previous problems. Okay, we're going to go over this one, and then we're going to go back and rate it. So, what do I want you to change ln into? Log base e. Yep, Euler's number. So the only thing I've done is I've just changed ln and substituted in log base e. Now eventually, this is just the first day with this, eventually you're going to learn how to do this and not have to substitute. You can just leave it as ln if you wish. So now I'm going to switch the x and y. On the right hand side, we want to peel things away until y is by itself. Robert, what's the first thing you think we want to get rid of? Log base e. So you focus on whatever the base is. It is the number e. Write it on the left and right hand side. Now on the right hand side, I get to cancel out log base e along with e. And then back to a similar situation that we had in the previous problem. So we want to solve for y, which means I need to find a way to eliminate the 5 and bring down the y. And we're going to do that with logs. And the number, or the base we use for the log, will be the number we're trying to eliminate, which is 5. So do log base 5 on both the left and the right. Then include what was already there. The log base 5 and the 5 cancels. We bring down y, and I'm going to write it over here. The inverse of y is equal to log base 5 of e raised to the x power. Because that is much more difficult than what we've been doing, I want you to choose one person at your table, one person, to re-explain number 6. I think you can do it in 20 seconds or less. Ready? One person, go. Make sure everybody's listening. Thank you. Do me a favor and be honest, it's totally fine to be at a 1 or 2. On a scale from 1 to 5, 5 being you feel like you've mastered this concept, you understand it, how well do you understand right now numbers 5 and number 6? 1 through 5? So it looks like most of us are at a 3 to 4, some of us are at a 5. Okay, let's go down to number 8. Do you see how 8 and 10 look very similar?
Yes.
I'm going to go quickly through number 8. You'll do 10 afterwards. First thing, switch the x and y. Now, there's something different about this problem than any of the problems we've done before, and that is we have a number that's stuck to it in front. It's stuck by multiplying. Opposite of multiplying is dividing. To divide by the exact same number you're trying to eliminate. And whether you put the negative sign down below or up top or in the middle, it doesn't matter as long as there's one negative. Okay, going back to eliminate the log base 3. So focus on what the log is. The log has a base of 3, so that 3 will now become the base for both sides, and what's already there will become the exponent. In doing so, I get to cancel out the 3 and the exponent log base 3. The y comes down, and I have the inverse of y is equal to 3 raised to the negative x over 4. Yes? Say it again.
Wouldn't it be like, because it's a negative exponent, would you turn it into a fraction or not?
Nope, you don't have to.
Okay.
Yep, great question. Okay, ready? Please do number 10. Yes or no?